Hey guys, and welcome back to the YouTube video. In today's video, I'm going to be explaining to you how a convolutionary neural network works. So, I'm sure you guys would have heard of what a neural network is and would have be having a basic understanding. And if you don't, then obviously there are videos on my channel which you can check out. So, till now, all of the neural networks that I've made are fully connected layers with some dense layers in them, but none of them are some convolutionary neural networks. So a convolutionary neural network or a CNN is typically just your standard neural network, but with some things called max poolings and convolutions. I will not get into max pooling in this video, but I will get into how convolutions are. So if this is our neural network, then this will be the input layer, and this will be the dense layer or the hidden layer. Now the role that the dense layer plays in a neural network is that it will analyze the information in the input layer. So basically, the input layer will feed the information to the dense layer, and the dense layer will process the information and get us some valid output, which will be passed to the output layer and be shown to the outside world and the humans. Because the input layer can only be seen when you are actually programming the neural network, and the dense layers cannot be seen. So what a convolutionary neural network does is, before going to the output layer, another layer is added over here, which is called the convolutionary layer. What the convolutionary layer does is that it will take the information from the dense layer and it will process the information and will grab a specific characteristic from that information. Like if we are processing the information of a dog, the convolutionary neural network will grab some things like the cause where the ears of the dog are. For example, let me actually show you a quick example. So in the last video where I had created this horse and human neural network that can classify horse and humans, um, we had not used any convolutions in it. So what ended up happening is that the model did really well on the training data that we gave it and did horribly on the evaluation data that we gave it. So that's why we use convolution. So what these convolutions will do is they will look at the image of a human and a dog and they will take some unique information from both of them. For example, a horse, I'm sorry, and for example, in a horse, the ears are protruding like outside and they're pretty long, and also the curves of the horse, like in the head of the horse, and even the head of the horse is pretty long than a human. Now, it's upon the network what it wants to grab, but let me actually show you. So, this is a horse. You can see a horse has a tail. The legs of the horse are like they are pretty thin when compared to a human, but they are pretty strong. Also, a horse has like a kind of a protruding neck outside, so the pixels over here are kind of projecting outward from the body of the horse. And you can see this is a really good example. So, what the convolutionary network layer will do? It will take some XYZ information from you, and it will process that information. Then, what will happen is that the convolutionary layer will send all of that information to the output layer, which will allow us to get a greater output and will also help our model do really well on some real life data. So that is how a convolutionary network works. Now let me actually get into some of the mathematical terms of a CNN or a convolutionary network. Now, so the how a convolutionary network works is on simple multiplication. So what we do is we place a bunch of filters in a convolutionary network. So the filters are the amount of data that we want to process in like one iteration. So, um, so what will happen is that the if we give it a filter size of 3 by 3, then it will like make a sort of a grid over here. Let me actually quickly make that of 3 by 3 over here in within itself, and it will take this and it will project itself on the pixels of the horse or any data that you are playing with. So what will happen is that if let me just make a little difference, um, and let me just so if these are the pixels of the horse, I know I'm totally butchering the drawing, but still. So if these are the pixels of which the horse is made up of, all of these pixels, let's just say, are assigned a certain value. Now, a lot of times these values are the same, but it also depends on how the where it displays out of that. So that's how the computer actually thinks and classifies the information based upon these values. So I'm going to replicate this now. So what will happen is that let's just so this one is the actual one of the horse, and all of these will having some random values. I'm just gonna say something like X. Now the filter that we have given is obviously the 3 by 3 filter, which we just talked about. Alright, I think I need to put it. Okay. So as I told you, the filter that we are taking into perspective is a 3 by 3 filter. So the 3 by 3 filter, what it will do is it will go on top of these pixels and it will draw mark an area where which it occupies. So in this case, it's going to be this much. So then what it will do is it will calculate the product of I'm sorry, this block, and it will project it over here in this much area only. So what it will do is once that is done, it will move across or down. Now in this case, you can see I've drawn a pretty small grid, so it will not work, but it's not how it works. So then it will move besides, and it will calculate the product of here. Again, it will be something like X, and it will again transfer it over here. And these two grids that you're seeing are of the same size. So yeah, there you go. So that is how a convolution works. Now, if you want to understand some more, there are also some other explanations and some Excel spreadsheets that you can look at. You can also, if you don't get it and you're still a bit confused, you can go to Google and just search how how does CNN work. You can just go and Google it up. Then it will tell you how it works by using the filters which I just told. Now, according to me, I don't know. I just feel that convolutions really work nice with image classification neural networking, because in text classification convolutions matter, but I don't think that much. And then audio classification, like yeah, they matter, but I don't think they matter that much. So this is a complete convolutionary neural network that I'm making right now. So this is a CNN. I know all of you would have heard a lot of people talking about CNNs, so this is how it works. So if you do not understand the mathematical aspect of it, it's pretty simple. It's just multiplication and then replicating the value from here to here. So many times when you're using a convolutionary neural network, it won't work, like it will throw you some sort of an error. That's because the grid that this is forming and the amount of filters you are giving does not match properly. So yeah, so you need to have a good amount of information on the data you are doing it, all of the classifications on. Otherwise, it can like it won't work. So that's why just take that into perspective before making your own CNN. So yeah, so let me quickly just label these layers so you guys can understand better. So this will be the input layer, this will be the first hidden dense layer, or a lot of people actually even place convolutions directly, but I like to do it this way. This is our convolution and this is the output. Now I want to get this thing clear. Whenever you are using a convolutional neural network, you when I just explained that they can detect specific patterns, it's not always it can detect very complex patterns. When you are just making like one convolution in your network, chances are it will detect a pattern that's so, I would say, small or not important that the accuracy will not even change. If you want the neural network to like detect really complex patterns like faces of dogs and cats and just give you 100% accuracy, you need to add some more convolutions, like maybe three, maybe four, and you need to even add some more parameters in there. Like you can just add the basic convolution, or it won't work. And also you need to add max pooling and a ton of more things which are pretty advanced. So yeah, so it's a this was like pretty short video, like just 11 minutes. It's okay, but I feel like convolutionary neural networks are pretty important when you are dealing with machine learning and neural networking. And if you don't understand how it works, then it's pretty bad, knowing that you like machine learning and don't know the fundamentals. So if you have any questions, let me know in the comments. I will be more than happy to help you out. And also, I'm going to be posting a lot of neural network tutorials and also a live stream coming up. I can't tell you the date. I feel like I will post it on the 13th of October. So that is when the live stream is going to be coming. So you guys can join the live stream. I'm going to be creating some neural networks, and or I have like either two plans, either a neural network or a pie game. You guys can let me know in the comments what you want to do. Like you can vote in the comments what I need to do, and I will do that. So that is like all of my future videos coming out. And if you have even any questions on how to add any convolutions to any other neural network, like one you are working on right now, you can let me know. I will try to help you out. Like I will try to help you out, but I can't promise because I'm not the best at neural networking right now. So yeah, so that is what just wanted to get clear. And now let me just give you a quick little challenge. My challenge is that you use the horses and humans network that I made and posted a video also in that just yesterday. You need to take that and you need to make a convolutionary network out of that. So just add even a single convolution is okay, but just add one. It does not like matter if you want to add like 10 convolutions. That's pretty good. I will be really happy. But if you even want to add just a single convolution, it's okay for me. So that's my quick little challenge for you guys, which I hope you guys really like and want to work on. Um, just post it down in the comments that you made that, and also link the GitHub repo or even the Google Colab or Jupyter Notebook, whatever you are using. Link it down below, and I will check it out and see how you went around the problem and how you made the solution. And I will like it. I like it. I'll give a comment say heart and reply whatever I reply on my comments. It does not really matter, but still. But that's like my challenge, and I hope you take it. And I want to see some healthy competition in the comments. So that is it for today's video. If you did like this video, like to the channel and subscribe to the channel. And until the next time we meet, bye bye.